Before microservices, there was a bigger, bolder idea, and it quietly ran the corporate world for over a decade. Everyone talks about breaking apps into small services now, but the first serious attempt to do exactly that had a name, a philosophy, and one very ambitious piece of plumbing at its core. On screen, it's just 3 letters. Out loud, it's service-oriented architecture, the granddad of everything we now call microservices. Understanding it is the fastest way to understand why modern software looks the way it does. So let's rebuild the whole idea from scratch, one piece at a time until it's obvious. Picture a huge company in the early 2000s, a bank and airline, a giant retailer. Over the years, it piled up dozens of separate systems. One for billing, one for inventory, one for shipping, one for the website, one for the call center. Each was built by a different team in a different decade in a different language. And they all needed to talk to each other, so engineers wired them together directly. Billing to inventory, inventory to shipping, shipping to the website, one custom connection at a time. With a handful of systems, that's fine. With 50, you get a spider web of point-to-point links that nobody fully understands and no one dares to touch. Change one system, and 3 others break in ways nobody predicted. Adding a single new application could mean months of custom wiring to everything it touched. This tangle even had a nickname, integration spaghetti. And it wasn't a small annoyance. It was slowing the entire business down, and every executive could feel it. So architects proposed one clean idea. Stop thinking about systems and start thinking about services. Instead of 100 tangled applications, describe the business as a short list of reusable capabilities, the things the company actually does. Paying a customer, checking inventory, booking a shipment, each of those becomes a self-contained service with a clear boundary. You don't care how it works inside, which language, which database, which server. You only care about what it offers and how to ask. Think of it like a company org chart. Instead of one giant blob of code, you carve the business into departments, and each department exposes a front desk anyone can walk up to. That shift from tangled code to clean business services is the whole heart of service-oriented architecture. Everything else is just the machinery that makes it real. Start with the word service. In this world, a service is a big, meaningful chunk of the business, not a tiny function. Think payments, think customers, think inventory. Each one owns a whole domain. The payment service knows everything about charging cards, refunds, and receipts. The customer service owns profiles, addresses, and preferences. Any app in the company that needs to take a payment doesn't build its own. It calls the one shared payment service. This is deliberately coarse. A service here is chunky and business-shaped, closer to a whole department than a single method. Hold on to that word, coarse, because it's the very first thing that separates this from the microservices you hear about today. Every service publishes a contract. This is the part that makes the whole thing click. A contract is a formal, machine-readable description of exactly what a service offers, which operations exist, what you have to send it, and what you'll get back. In the classic era, that contract was written in verbose XML, using strict standards with the names now on your screen. A program could read that contract and instantly know how to call the service. No human phone calls, no guessing. The trade-off was weight. The messages were heavy walls of XML, wrapped in envelopes, slow to produce and slow to parse. Formal and reliable, yes. Lightweight, absolutely not. But there was a real superpower hiding in that formality. Because the contract was so strict and so standard, a service written in one language could be called by an app written in a completely different one. A decade-old system and a brand new one could suddenly speak the same protocol. That interoperability was a huge part of why the whole idea took off. Just remember that weight, because it comes back to haunt the story. Here comes the centerpiece of the whole design. You've got your services, payments, customers, inventory. Now, how do they actually talk to each other? The old answer was direct connections, and we already saw that turns into spaghetti. So this architecture introduced one big shared piece of plumbing running down the middle of the company: the enterprise service bus. The bus for short. On screen, just 3 letters. Picture a single backbone that every service plugs into, like appliances into a power strip. Nobody wires directly to anybody anymore. You hand your message to the bus, and the bus delivers it. And it does far more than pass things along. The bus can translate formats, route requests, enforce security, and log everything in one central place. It is the switchboard for the entire enterprise. Follow a single request through the system. The website wants to charge a customer. In the old world, it would open a direct line to billing and just hope the formats matched. In this design, the website simply drops a message onto the bus, please take a payment. The bus looks at that message and figures out who should handle it. It transforms the data into the exact format the payments service expects. It checks that the caller is even allowed. Then it routes the message to payments, waits for the reply, and hands the result back. The website never knew where payments lived, what language it spoke, or how it was secured. It only ever knew the bus. That is a genuinely powerful property. The website and payments are now loosely coupled. You could rewrite payments completely, move it to a new server, even swap its language, and as long as the bus still knew how to reach it, the website would never notice. Everything flowed through that one central channel, and that's the detail to keep in mind. This unlocks the real payoff, the reason companies bought into all of it. Reuse. Build the payment service once correctly, and every other part of the business can use it. The website, the mobile app, the call center tool, the partner portal, they all call the same payment service instead of each reinventing it. One team owns it, fixes it, improves it, and everyone downstream benefits at once. In a giant enterprise, that promise was enormous. Stop rebuilding the same capability in 10 different departments. Write it once as a service, publish its contract to a shared catalog, and let the whole company assemble new applications out of parts that already exist. That was the dream, the business as a set of reusable building blocks. All of this needs rules. When dozens of teams share the same services and the same bus, you can't have everyone doing whatever they want. So service-oriented architecture came with heavy governance. There was usually a central architecture team that decided how services should be designed, named, versioned, and secured. Every new service had to be registered in a shared directory so others could actually find it. Standards were mandatory, and this governance was both a feature and a curse. On the good side, it kept a giant organization consistent. On the bad side, it was slow. Getting a new service approved and onto the bus could mean committees, review boards, and months of waiting. Versioning was its own headache. Change a contract that 10 other teams depend on and you have to coordinate all of them at once or risk breaking half the company. Hold that thought because speed is exactly where this model would eventually lose. Here is the number that defines this whole architecture. 1 bus. In the classic design, the entire company routes its traffic through a single, shared enterprise service bus. Every service, every message, every department, all funneled through that one central piece. When it works, it's elegant. One place to route, translate, secure, and monitor everything. But look at that number again. 1. A single thing that everyone depends on is also a single thing that can slow everyone down or take everyone offline at once. That one bus is simultaneously the best idea in the design and its deepest flaw. Keep that single number in your head because the next chapter is exactly where it cracks. Now line it up against microservices side by side. They come from the same instinct, break a big system into services, but almost every choice is the opposite. Service-oriented architecture uses coarse, business-sized services. Microservices go small and tightly focused. The old model routes everything through one shared, smart bus. Microservices skip the bus entirely and let services talk directly, keeping the network dumb and simple. The old model often shared one big central database. Microservices give each service its own. The old model leaned on heavy XML contracts and central governance. Microservices favor lightweight web calls and small independent teams. And deployment flips too. In the old world, you often shipped the whole platform together, while microservices let each team release its own service on its own schedule without asking anyone. Same starting idea. Two very different philosophies, one centralized and governed, one decentralized and independent. So why did microservices win? In one word, the bus. That central backbone, the very thing that made the design elegant, slowly became the bottleneck. Every message paid a tax just passing through it. As traffic grew, the bus turned into a performance choke point and a single point of failure. When it struggled, the whole enterprise struggled. Worse, the bus got smart. Teams kept piling routing logic, transformations, and business rules into it, until that shared middle became a tangled monster of its own, owned by a central team that every single project had to wait on. The industry's answer was blunt: make the pipes dumb and the endpoints smart. Pull the logic out of the middle, push it into small independent services, and let them talk directly. The timing helped too. Cheap cloud servers and lightweight containers suddenly made it easy to run dozens of tiny services, each deployed on its own, without a giant central platform holding them together. That move in the 2010s is what we now call microservices. Real companies lived this. The most famous example came from Amazon. Around 2002, an internal mandate reportedly went out. Every team must expose its data and functions through service interfaces, and that is the only way teams are allowed to talk to each other. That single rule pushed the whole company to think in services, and it's often credited as a seed of both this architecture and the microservices that followed. Netflix made a similar journey, moving off one giant application into a fleet of services as it scaled to the whole planet. And an entire industry grew up selling the bus itself, enterprise integration products from the vendors whose names are on your screen. Banks, airlines, and telecoms ran their operations on this design for years, and a lot of them still do. You can still see this defined in black and white. Every major cloud and enterprise vendor keeps a page explaining service-oriented architecture, what a service is, what the bus does, and how it stacks up against microservices. On screen is a real reference page describing the exact model we just built together. This isn't ancient history buried in a textbook. It's living documentation because a huge amount of the software running the world today was built this way, and it still runs. If you ever join a large, established company, there is a very good chance you'll meet a bus, a service registry, and a whole lot of XML. And now you'll know exactly what you're looking at. Before we wrap, 3 things people get wrong. 1. This is not just old microservices with a beard. The whole point was the shared, smart bus and Coarse, reusable services. That centralization is the defining trait, not an accident. 2. The bus was a trade-off, not a mistake. For a big enterprise that needed one place to secure and monitor everything, it genuinely made sense. It only became a problem at massive scale. 3. It never actually died. The name fell out of fashion, but the ideas, contracts, service registries, reuse across the business, quietly live on inside modern platforms and API gateways. Different label, same DNA. Let's lock it in 3 lines. First, service-oriented architecture breaks a big system into coarse, reusable business services like payments and customers. Second, those services talk through one shared, smart backbone, the enterprise service bus, which routes, translates, and secures every message. Third, microservices kept the idea of services but threw out the central bus, going small, direct, and decentralized, so no single piece could hold everyone back. Core services, one clever bus, heavy governance, that's the granddad. Small services, no bus, independent teams, that's the grandchild. So that service-oriented architecture, the ambitious, centralized idea that taught the whole industry to think in services, then handed the torch to microservices. If this made the history finally click, subscribe. The entire point of this series is turning intimidating jargon into pictures you can't forget. Next in the series, Microservices Explained Properly, where we take everything you just learned, throw out the bus, and see what breaking things down really small actually gets you and what it quietly costs. It builds directly on this one. I'll see you there.